Hi everyone, welcome back to Geeks for Geeks. Today we have another DSA mock interview, and our guest for today is Vinit Joshi. So I'll like to invite him to the stream, and we'll start with this webinar. Hi Vinit, how are you?
I'm fine. How are you?
I'm fine as well. So can you please introduce yourself to the audience?
Yes, yes. I am Vinit Joshi. I am from Delhi. I completed my schooling from Vidya Bharati School and I am pursuing my BTech at Mahavir Swami Institute of Technology. I love programming, so I decided to choose programming language is C++ and JavaScript. And I love to create things on web, so I decided to take the MERN stack programming and and I completed my internship at Hey Coach as a front-end developer role. And then I have solved around 300 data structure problems on GFG and lead code as well. Yeah.
So can you tell us like some like what's your best project or what's your major project? Can you tell us something about that?
Yes, the latest project I made is the LearnTube application. It's a MERN stack application where I have put around more than 170 plus data structure problems on there. And when we click on the questions, it fetch the data more than 5 to 6 videos by views on the YouTube. So it will fetch the YouTube data on our site so that the YouTube distraction will not happen. Like the YouTube recommendation algorithm sometimes show you the unrecommended videos which which distract us sometimes. So
Okay, okay.
yeah yeah
And like,
that's it.
have you thought of adding some more features to this project of yours?
Yeah, I have added a compiler and a whiteboard. Compiler
Okay, so
means
you have
it,
added a
it has,
compiler as well.
yeah,
So
more
that
than
means
six
if
languages.
okay, right. So like as you like, I think everyone can hear me in the chat. So as you all must be knowing, we'll be having a DSA mock DSA round, and in this we'll be discussing two or three problems. That depends, and we'll like so I'll give you the access to Google Doc. One second. So you need in the private chat, you can see that I have shared a Google Doc link with you. So you
Yeah,
need
yeah,
to open this and share your screen as well. Like down there, if you will see in your screen, so you will have a share option. So you can share
yeah,
your
yeah.
screen and open this Google Doc at the same time. And I hope that everyone is as excited for this mock interview as we are. And I can assure you that I have like I have picked two problems or three problems for today, and these problems are really good. And today we'll be changing a little bit of format. Like I'll like the coding format will change for today. So I hope that you are as excited as me. Okay. So like, can you share your screen?
Yeah, I'm just doing it.
Okay,
Can
perfect.
you see it?
Yes, I can see it. So can you open the Google Doc for us?
Yes.
Perfect. So let us have a look at the first question for today. So the question is that basically I will give you a linked list. Okay. So basically what will happen? I'll give you a linked list. Like I'll give you two linked lists. Okay. So those two different linked lists are representing polynomials, right? So like what is a polynomial? So a polynomial is, let's say, 3x square plus 7x plus 1, something like this. Or it can be, let's
Mm.
say, 7x cubed plus 5x square plus 2x plus 1, like this. Okay, so I'll give you two polynomials, and those two polynomials are gonna be represented in terms of a linked list. So what your task is that you have to add those polynomials up. The like simple polynomial addition is very easy, right? But what you
Yeah.
have to do is the polynomials I'll be giving you, they are represented in the form of the linked list. So what you have to do here is you have to add these two polynomials up in the linked list, and then what you have to do is you have to return the resultant linked list. Okay, is the problem
Mhm.
statement clear to you and the audience? Like in the audience also, is it clear to everyone? Vineet, is it clear to you what you have
Yes,
to do
it
in this?
is clear to me. Yes, it is clear to me.
Okay. Okay. So like let's take a sample example. So if I take a sample example, suppose that the first linked list is 1x square. Okay. So basically,
Mm.
if the first linked list is x square and the second linked list is x cube. Okay. So do you remember how we add up the uh, uh, polynomials? So we first of all add the polynomials, like we add the terms which are having the higher degree. Yes or no? You must be
Yes, yes.
remembering this thing.
Yeah.
So
Yeah.
like in terms of writing format, what we do is first of all we write the higher degree polynomials and then the lower ones, right? So in this case,
Mhm.
if you I add x cube in the like that is in the second linked list and then x square, so the answer would be x is like x cube plus x square, right? Now if I
Mhm.
have a look at the second test case, so if you can like if you can scroll down for us a little bit. Okay, so if you look at this test case, so in this test case, what I have been given is I have been given like I have been given like one x cube. Okay, like basically x cube plus 2x square is the first polynomial, and the second polynomial is 3x cube plus 4x square. So what will happen? I'll first of all add the polynomial x cube with x cube. So like x cube with 3x cube. So the answer will be
Mhm.
4x cube. Okay, and then what will happen? I'll
Yeah.
add the like polynomial with the square, right? So that's nothing but like I'll add x square. So like that is having the this x square term. So I'll add these two up. So
Yeah.
2 plus 4. So that's nothing but 6, and 6 is 6x square. So I'll basically like
Mhm.
in the first node it will be having 4x cube, then it will be having 6n square, and then it will be pointing to null. So is the problem statement clear to you and everyone else as well?
Yes, problem statement is clear to me.
Okay. So like we need how do you think that we should approach this particular question now if it's clear to you?
I mean, first we have to create a node which have the two variables, right? First is the value, and second is the string. So because it has the x2 value and also a character. So I have to create a node which can store two values
No,
and an address as
okay.
well.
So
Yeah.
you are saying that up, like you are saying that up, like when we talk about a normal linked list, let's say 6 is pointing to 7, then 7 is pointing to 8. So in that case, what we have is our node has some data and it has the address
Yeah.
of the next pointer, right? It has this thing.
Yes. Yes.
So
Yeah. Yeah.
here, what I'll be giving you is I'm telling you this information that I'll be giving you here the node, and the node will contain the value, the numerical value. It will contain the coefficient power, right? It will contain the power. Okay, it will contain the power
Okay.
of
Okay.
x, like it will contain the coefficient, it will contain the power of x, and
Mm.
then it will also contain the pointer to the next node.
Okay. Okay. Okay.
So you don't have to implement this node. So how
Okay.
will you
Okay.
do this?
Firstly, we have to check for the degree, right? Because the degree is important over here. For the x cube, let's say I have a degree of x3, and
Okay.
I've also created a dummy node of
It is
the
okay. So do you think that the first term of both the linked list are going to be of the same degree, or they can be of different degrees?
they I think they can be of different degrees. I think it is not mentioned that will start from the same degree. So I think they
Okay.
can be of the different degree as well. Yeah. Yeah.
So like how will you approach it in that case? Because if the same degrees were there, then what will
Then
if
I can
suppose that
just
the same degrees
directly
were
add
there,
it. Yeah.
you could directly add them up and then move your
Mm,
pointers. Okay.
yeah.
So if they are of not of the same degree, then in that case, what are you thinking?
I have to check which one is the higher degree first. Then I will take that value. Let's say
How
in
will you
this
check
case
that?
it has
How will you check that?
firstly, what is this data type will be? Let's
like
say
like
x2 is given.
basically it will be power, right? It will be integer. Basically it will be power. I'll give you power, right? A node will contain the
Okay.
data in integer in integer data type. It will contain the power in integer data type. Power will represent the power of x, and it will
Okay.
contain the
Okay.
pointer to the next node. So basically if it's x square, so power will be 2 here,
Okay. 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 Okay.
and the coefficient will also coefficient value will also be there.
Okay. Okay. For this, um, I have to take the degree out from the x cube, right? So what we can do for the degree is, um,
Basically how will like you are stuck with how it will be represented in a node.
no, 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 no. I want to know how will I get the degree. I want to get the degree, right? Degree is the main key here.
Yeah, I'll
So
tell you this thing. So basically, if I see here, so basically when let's suppose that you have a node, okay, you are currently at a particular node. Let's say you are at the head of the linked list. So if you do head
yeah.
data, then you will get the data, right? You get the data in a normal linked list. But here will what will
Hmm.
happen if suppose that you are at the head. So if you do head, and then for the head, if you do heads, like if you do head power, so that will give you the power, like that will give you the power of x. So if the
Oh,
power is
okay,
2,
okay.
then it will be like x square will be represented with the power. Okay, and if you do heads coefficient, right, like this coefficient, so it will give you the numerical value. Is it clear?
Yeah, yeah,
And
yeah.
head
Now
next
now
will
it's
give you the
clear. Yeah,
next. So
yeah,
this
yeah.
is what will happen. So now
Okay,
you
okay,
can tell
okay,
me.
okay. Yeah.
For
Um,
everyone in the chat, yes, this is an Amazon interview question. Okay.
First,
So,
yeah.
like, how are you going to add it? Like, do you think that there are some constraints in terms of addition? Suppose, like you are wanting to add in such a way such that the terms that are having the higher coefficients, like higher powers, they should be coming first of all, right?
Yes, yes, yes.
So
Um,
suppose that what
okay, so power will give me the degree. So first I have to check whether the degree has the highest power, right? So you said the head of power will give me the power. So
just for any node.
I,
So if
yeah,
you
yeah,
look at
yeah.
the second test case, so I want you to give me some observation like how the linked list has been given. If you look at the second test case for linked list 1 and linked list 2, so can you tell me some observation that you are having for the first and the second linked list, how they are having the orders, how they are having the powers for each of the x.
Yes, it has a decreasing order of the degree. First x cube, then x square, and then I think it is it in the
Yeah.
decreasing order of the degree. Yeah.
So basically, what I'll be giving you is I'll be giving you the linked list in such a format such that the powers are in both of the linked lists, the powers are decreasing one by one. Okay, is that clear? So you
Hmm.
don't have to sort it.
Yeah, 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 yeah.
Otherwise, if,
Now I
otherwise,
get it.
otherwise you might have to sort it. So now what will you do?
Mm-hmm. What I will do is, let's say, first I will check the list at. I will also check link list one and link list two at the same time. Which one of the, let's say, which one of them a higher degree? Let's say in this case, it has a power two, it has a power three, right?
Okay, so how are you
And
going to check this?
I will compare it. I
What
can compare
what
it
will you
if
compare?
what
You will compare both the pointers, or what will you compare?
their power. I mean, head one.
Okay,
Let's say I have the head one for linked list one and head two for the linked list two, right? I can check if the which one is higher. H1 of power is less than H2 of power, so I can say that H2 of power is higher. So then I can add the coefficient. I mean 1x raised to the power cube in my um, it has to be in the answer. I mean, what will be the output format like this? I mean, the
yeah,
node
yeah.
plus.
Basically, the first node will be first node will be containing the coefficient as one, the power value as three, and like it will be the next node of that will be containing the coefficient as one and the power as two in this case, and then the null. It will point to null. So basically, do you think that you have to make some linked list, or you have to do something for returning the answer? What are you thinking? How will you return the answer?
um,
Audience can also tell me have they understood this problem, and they can also tell me like how are they thinking to approach this, because this is a good question. So it's a medium level question, so everyone can try it out, I can say that. So how do you think that we should approach it further?
Output. I think it can be of the in the addition format. So we can say that the string format will be good. I think
No.
because
Basically, the final format will be in linked list, right? You have to return the head of the linked list. You basically
okay,
have to
okay,
return
okay.
the head of the linked list. Okay, you have to return the head of
Yeah.
the linked list that is containing the addition overall
Okay, okay,
final
okay. Yeah,
format
yeah,
of
yeah.
it.
Understood now. Yeah. I can directly firstly, let's say I found this x3 has the greatest degree from which one, then I can take this one as a head over here, and and after that I can move its head, and then I will check that if x2 of degree of x2 is 2, right? It is a smaller than, and x2 is I mean the h1 of next is pointing to null, right? And h1 H1 as the has H1 is not null right now, right here, and then after that I can connect H2 by H1, like
So you need to return a final linked list. So like
yeah,
will you make a new resultant linked list for yourself, or what will you do?
I don't think I should be able to create a new linked list, because if I can connect with this 1x3 and 1x2, it will be the same result, right? The right now we what we have over here.
Okay.
Yeah,
Okay. So what I will do is, just 1 second, give me. I will give you. I have in the private chat. I have given you a question link for the same. So can you open it? If you will see in the private chat, I have given you the link for this question. So can you just open it?
yeah,
Okay. So you just need to push the full screen button for the coding part, so that we can write the code more efficiently and you can understand it as well. Yeah,
okay.
you can just do a full screen part there on the right side. Yeah, perfect. So as everyone can see, right? As everyone can see, so if you will observe here, right? So what are you able to observe? So you can see that a particular node has a coefficient, it has a power, and it has the address of the
And
next
there's a
pointer,
null.
right? So
Yeah,
now
yeah,
the
right.
structure of the linked list is very much clear to you, and the
Yes,
function is
yes.
there. You don't need to write the full code. You don't need to generate the nodes and things like that. You will be given all
Mm,
these implementations internally. You just need to add, like you will be given the access to the pointer of the first linked list, that is containing the polynomial, and the second linked list that is containing the polynomial p1 and p2 respectively, and you need to return the head of the final resultant linked list. So now you can tell me how will you do this. So you can tell me how will you approach now. Like audience can also
okay.
open this question if they want.
Okay. Let's say I have two pointers, right? P1 and P2. I will I can check if P1 exists, or and also P2 exists. First thing is I can check is that if P1 has the same degree or not. P1 of power, P1 of power and P2 of power. If it has the same degree, let's say if it has the same degree, then what I can do is I can I can add um P1 and P2 can have different lengths, right? It does not it
Definitely they can have different lengths.
uh, for let's say mm, let's say I can create a new node for that, because I think I might need to create a node, because if we have a different length, we don't know how many lengths it can to extend. So I think I have to create a new node, say head pointing to null right now initially. Let's see,
Okay, so
new.
you will make a head for yourself, and that head is initially having the node.
Yeah, 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 yeah. I think it will have the node for coefficient. I am just putting the dummy values, because it should contain some values, right? Because I'm passing it. So let's say I
Okay,
am
so
passing power 1 1. Yeah. Then what I can do is I can
is
add
it is
these
it is it
two.
optimal to pass 1 1? Like will you return, like in that case, if you return the head of the linked list, then this node that is 1 1, which will represent 1x square, it will also be returned in the answer. So are you going to do this, or you are going to do something else? If you return
Um,
this
uh,
head,
yeah, yeah, it will get added. Yeah, yeah. I think 0 0 will be good.
but again, if you still
Yeah, yeah,
return the head,
0. Power will become 1. So yeah. Mm,
but I'll say you are thinking in the right direction. Can you think a little bit
yeah,
more?
yeah, 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 yeah. I'm just thinking of the
So
optimal
should you
value.
return the head, or should you return something? else. Suppose this node is there. Then after this node, you have the complete linked list added, right? Complete polynomials, all the terms are added one by one. So
Yeah.
will you return this node, or will you maybe you will try to do something else?
Um, let's say that I have put the dummy value, right? And on the next, I can return the head of next, because let's say I will have head, and I can add which, if it is equal, right? If it is equal, it doesn't matter what value I return. I can just add the values and connect to the node. Let's say
Okay.
I have one power x square. I mean one x square plus.
Oh, can you
Two.
just increase the font a little bit by doing a control plus or something? Yeah. Now. Okay.
I
So
think
how
it's just
it's
too much.
no, 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 you don't did not need to do this much. You can decrease it back. Okay. Don't go before like beyond 125. Just till 125 is fine.
Okay, okay.
You can full screen it again.
Yeah, yeah, yeah.
Yeah. Now.
Let's say I have a 2x power 2, right? Let's say it has a one node of over here. I mean head one, P1 contain this value and P2 contain this value, right? Both has the power, or the power is same, and I can just add any pointer. Let's say I add this value, add P2 value in P1. Then what I can do is I can connect head to this pointer, which will contain the equal value like 3x square. So P1 will have all the values. P1 have the sum, so I don't have to. I just need to point it now. Head will point to the P1 because it has the same value, so it will not be much of a case. I mean, it will not be a problem then. And hello, my voice is audible.
Yes, yes. Your voice is
Yeah,
audible.
yeah,
So
yeah,
like,
yeah.
what will you do in that case? If the powers
I
are the
mean,
same, then if the
then I
powers
will
of
add
two
it in.
numbers are same,
Yeah, yeah. When the powers of two are same, then I can add it in any one of it, right?
so what will
Let's
you
say
add? What will you add?
I will add the powers and the coefficient as well.
Will you add? You will add the powers.
Yeah, yeah. No, no, power not well, not with add the power. I will just add the coefficients. Sorry,
Okay.
coefficients. Yeah, 2 + 1 3x cube, 3x square will be, yeah, coefficient plus equals to coefficient, and then I can just point head. Head of next will be pointing to P1, P1, and then P1 gets updated. P1 of next if the power are same, and also P2 gets update as well. P1 of next, yeah. If the powers are same. Else, else if my powers are of P pointer P1 has the greater
Okay.
power, then I can take the P1 pointer, right? So I can just add the head of next. So let's not take a head over here. Let's take a tail as well. Tail is pointing to head as well. So I can just move over
Why are
here.
you taking a
Tail,
tail in this case? Can you tell me? Can you tell us why you are
because
taking a tail?
if I am adding head, I am also updating the head over here as well, right?
So what will happen
I'll
in
have to
that case if
update
you
that.
keep on updating your head?
Head will be pointing to null, and my the first head, which is the contain the all, I mean all linked
So
list, I mean connected linked list will be lost. I will only have the null pointer last. So that's why I'm taking the tail as well. So tail will keep adding to
so
the next
you
next
you
next,
are saying
and
that
head
you
will
will have a
contain
tail.
its first value.
So tail will contain what? Tail will contain all the new nodes that you are adding up one by one. It will contain the access to that.
Yeah, 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 yeah,
Okay,
yeah. Tail of
perfect.
next, and tail is also gets updated, right? Tail of next and tail of next as well. Tail will be added to tail of next will be added to P1 of power. P1 P1, yeah. Tail one is will be added to P1. So it has a greater power. Else, and tail one is also gets updated as well. And then same for to P2. Tail of tail will be updated by tail of next as well. Now at the last, I can simply return the head of next. I think it will work out. I
Okay, so
think it
why
will
are you
work out
returning your head next? Can you tell us again? Because
because I have created a dummy node over here, right? I don't want to this to be included in my answer. Let's say I
perfect. So
have 1x square and 2x square. It will be added, and it will be added to the tail of next, right? Tail of next will contain the first value of the addition of the coefficients. So I will say that head of next, because head of next contain the dumb value, and head will contain the dummy value, and head of next will contain the entire summation of the polynomial answer linked list, you can say, right?
okay,
Head
right.
of next, yeah.
So now, if you are done with this, you can try to compile it.
Yeah,
Are you sure you are not missing anything? You can have a look at it once more.
yeah, yeah, I'm looking at it. I can see the edge cases if p1 is null or anything p1, or let's say if p1 is null, then I can simply return. So no, let's say I have a p1 is null, or p2 is null as well. P2
You
is
are
null.
using and
Yeah, I mean, let's say both given as the empty, so I can just simply return null here as well, right? Or we can say else if p1 is null and p2 exists. Let's say p2 exists, and then I can simply return the p2 over here, right? Or else if I can say p1, let's say p1 exists over here and p2 is null, I can simply return p1 over here, because it will contain, if one any one of them is left, one of is left, then I can return the other one, because if
okay,
this one contains and this one does not, so I can simply say this is my answer. So that is what I have
okay.
done over here, right? And I think this will work, this must work out. Let me compile it, if any error or not. Okay, it is showing me a runtime error. Okay.
So, like, why are you getting this error?
Okay. Okay, I have made a mistake. I did not update over P1. It's P1 of next, and I
So
also
you
did
you
not
you
update.
saw the case that I was talking about, like with like.
Yeah.
So that is why I ask you to go through once again.
Okay. I did not update my. Now, now I think it will work. I think it will work. My output is 1x cube, only 1x cube. Okay.
So
Um,
if you are given 1x square, like if you are given 1x square and the other linked list has been given 1x, then you are getting what? You are getting 1x cube.
yes, I mean, can you say it again? I did not
So,
get.
so I think what you are getting wrong is you are getting the first node as 1x square, second node as second linked list as 1x to the power 1, and if you are adding them, so you are getting 1x cube. So do you think, like, why do you think that it is this, it behaves like this? Have you done some
Mm,
mistake?
I think what can it be?
Like audience can also tell us like how they will be approaching this particular problem. It's a good problem, to be honest. Okay, so your output is just 1x cube. Okay, so why are you missing
Uh,
this? Okay, so can you think again, why are you missing this thing? So
I
like
think it
basically
does
what is
not
happening?
add the first node.
Yeah,
I mean, yeah,
so you are getting 1x square and 1x cube, so you are getting just 1x cube as the answer. So what does that mean? That means that
I'm
if
just
one of
getting
the
that.
linked list is getting exhausted and other linked list is
Mm.
still remaining, then you are in trouble. Your code is not working
Yeah,
fine.
yeah, yeah.
So can you think now? What will happen if
Yes,
one of the
yes.
linked list gets exhausted?
Okay, I have to manage the other cases as well. I mean, let's say P1 and P2, if one of them
Basically,
is lost, I mean, one of them is
you do
completed,
not
then I
you know
have to check
no, no,
for
you
the.
do not have to think for so many cases. You just have to think for some two basic cases. Like whenever the linked lists are going to get
Yeah, I mean,
exhausted,
let's
one of
say
the
that,
linked lists.
yeah, yeah, yeah. If one of them is going to get exhausted, let's say I know that if P1 can lost or P2 gets lost. So I have to check for P1, let's say P2 gets lost, then I'll I'll have to check for the P1 as well over here because let's say 1x cube, right? It checked the which one of has the higher value. It found at that 1x cube has the higher value, so it checked it over here 1x cube and it is
No, no,
updated its
don't
p2.
don't think of so much complexity, right? Don't think of, because you have even thought the edge cases to be a little bit more complex. You could have written it much simpler. But what I'm asking is, suppose that one of the linked lists gets exhausted, so the other linked list will be having some values. So can you think of a basic array question that can be done very easily like this? If I give you, let's say, if I give you merging two sorted arrays or something, so what happens when one of the arrays get exhausted? Then what do you do?
uh, okay, I can just simply add it in the previous link. Let's say um, I can just check. I just have to check if P2 is still exists. Then I can just simply tail of next will be added to the P2. That's all I have to do because because P2, let's say P2 has and P1 is get exhausted. So P2 has some values left in its node in its linked list. So I can just simply um, I can simply connect with it. Tail of next will be pointing to P2 or same for the P1. Tail of next will be P1. P1 over here as well. I
Okay.
think it will work. I don't have to do anything more than that. I think so.
Okay.
Yeah.
I think it will, but still there's a little bit of problem. But you can compile it now.
Yeah. Let's see.
So you got to know where you were getting this wrong, right?
I
So
got to
now
know.
you're getting the same output. Can you
I'm
try
now
to
getting the same
submit it
output.
now? Can you try to submit it now?
Okay. Yes, yes. Okay.
Okay.
Yeah.
So can you think of where your code might be going wrong? Can you think of this? You can even get a full screen and you can just run through your code. Before going forward, one more thing that I wanted to ask you is, if you're like, what are you doing? You are actually making a new linked list, right, Amit? You are doing this. You are basically making a new linked list. Like you are
I
basically
mean,
making a
I've
new linked
just
list in
created
which
a head.
no,
I
no,
think
no.
I just created a
Basically,
head. I mean,
yes, that's fine. But you are every time you are adding new nodes one by one. Okay, correct or not? One by
yeah,
one,
yeah,
new
yeah. I
nodes
am
of
adding,
the
joining
polynomials
it.
are getting added. So
Yeah, yeah.
can I say one more thing? That one more mistake that you have done is that what you have done is you have simply said that you have said this thing. This seems correct also, that p1 plus is equal to p2 next, something of this kind you have done, right? P1's coefficient plus is equal to p2's coefficient. But don't you think that the much better way of doing it is that you make a new node, okay? You make a new node, and in that particular node, the new coefficient will be p1's coefficient plus p2 coefficient, and the power value of that particular node. Yes or no?
Yeah, I can do it. I can do it. Yeah.
So you understood this part, like what I just said, like this part.
Yeah, yeah. I
Uh,
think
you,
I. Yeah, yeah, yeah. I think I understood it.
and
I
one more
can
thing that I wanted to ask: do you think that
create a
the
new.
you have written three edge cases, but don't you think that it can be reduced to like less than three test edge cases?
Over here.
Yeah. So if what if the first linked list is null? So in that case, what will you do? Suppose if the first linked list is null, in that case, what will you do?
I will just simply return the next linked list which is given here. If first is
Uh,
null, then I can simply return the other one.
like if the first linked list is null, then if the second linked list is existing, then even you will return the second linked list. If the second linked list does not exist, then it will be pointing to what? It will be what? Its first pointer will be what? If the second linked list also does not exist, in that case, it will be null.
It will be
Yes or
null.
no?
Yeah, yeah,
So
yeah.
in
It
that
will
case,
be null.
in that case, what will you do? In that case, also you'll return, like basically you'll
You'll
return null,
return
right?
null. Yeah, yeah. I will return null. Yes. Yes.
Okay, so can you think I think I am like there's a little bit of power cut issue here, but no problem. So can you think basically if the
Yeah,
first linked list is null, then you will
yeah,
simply return the second linked list. Okay, the
yeah,
basic case is there.
yeah,
But
yeah,
now
yeah.
since we are having lesser time, so maybe you can skip this question for now, and now we can try to move to the next question. Okay, because since we have lesser time and we have to discuss two questions, so can you just scroll through the Google Doc once again?
Yeah, yeah.
Okay, so if I'll quickly tell the audience about in the second part. So like in this question, what we have to do is I'll give you an array. Okay, I'll give you an array, and that array will consist of n different like n integers, right? They can be different, they can be same. I don't care, but like an array will consist of n integers, and I will give you a positive number k as well. And what you have to do is you have to find the longest subarray, like you have to find the longest subarray which is divisible by k, which is divisible by the given number k. Okay, so like many of us must have
Mm.
done this question, right? Longest subarray with some k, some zero, right? Longest subarray with some zero, longest subarray with some k, longest subarray with maybe a given zero or some similar questions. Yes or no? All of if all of the people in the audience can relate to this thing, that they must have encountered these kind of questions, right? Longest subarray with some zero, longest subarray with some k. But this question is a little bit the similar concept is there, but it is a little bit on the upper side. So in this question, what you have to do is you have to find the longest subarray which is divisible by k. Okay, so let us try and see. So in this sample, if you will see here, so basically suppose that I give you this array. Okay, so in this case, if I give you the array 2, 7, 6, 1, 4, and 5. So in this case, the longest subarray which is divisible by k is going to be nothing but 7, 6, 1, and 4. Because if you see 7 plus 6 is 13, 6 plus 1 is 14, and no, 7 plus 6 is 13, 13 plus 1 is 14, plus 4 is what? It's 18. So in this case, you can easily observe this part, that in this case, what is happening is, in this case, this sum is 18, and that is divisible, and that is the longest contiguous subarray, like that is the longest summary which is divisible by k. So how are we going to do that? Can you tell me the brute force approach? If the audience has understood this question, so they can hit the like button and they can give us a +1 in the chat as well. Has the audience understood this question? That we have to find the length of the longest summary which is divisible by k. So all of you can give us a +1 and write understood in the chat. Hit the like button as well. So have you understood this question now?
Yes, yes, I have understood the question.
Okay.
The first approach that comes to my mind is that create the, I mean, check for every subarray, like for two, for first, let's say I have two, right? Then I can say 2 plus 7 is uh, is 9. 9 plus 9 is also divisible by 3, right? But its length is 2. So I can check for the length. I mean, I can store the length. I can store the length if this is 2 length size. Okay. Then I can say 276. 27 plus 9. 9 plus 6 is 15. 15 is also divisible by 3. I can say 3 now answer will be updated by 3. Then I can say that 2761. 15 plus 6 is 16. 16 cannot be divisible, so I will not take this
So
one. Then I
can
can
can you
check for,
can you try to summarize what you are trying to say?
I can say that for create, I mean, for every subarray, I will add the sum and check for the length. I mean, which is a divisible by k or not. Let's say I took this subarray 276, then I will divide by 3, and then check if it is divisible by 3. Then I can store the length of it. Then I can do for 2761 as well. Then I can
So you are
2764
saying that
and
like at one point of time your left pointer will be fixed and your right will keep on moving by one, one
yeah,
by
yeah,
one,
yeah,
like
yeah,
that.
yeah, 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 yeah. Then I can move on for the 76145. Then I can do for 6145. Then I can 145 and then 45. So I
Okay,
can,
so can you just scroll down and write this a little bit brute force pseudocode for this?
yeah, yeah, yeah. I think I cannot edit this.
You do not have the edit access. I think
Yeah,
I
yeah,
must
yeah,
have
yeah.
you. You have the edit access or not?
No, I don't have the edit access. I cannot.
Okay, one second. I'll give it to you. Okay, now you can edit this. Just try to refresh
Uh,
this. I think it
okay,
will.
okay. Yeah.
So I hope that you have understood this question. And like in the
Yes,
audience
yes.
also, I like to say this question has been asked in Microsoft company. And previous question that was linked list polynomial, it is definitely an easy question. But many people were saying that it that is very similar to merging two sorted linked lists and things like this. I'll say that as well. But it is like if you implement it, like saying something and implementing is different. So I hope that you must have understood that question from that question that was asked in Amazon as well. And in this question, like now you can open it, you can scroll down now. I think now it will be fine. Can you scroll down?
Yes, yes. Now I can edit it. Now I can edit.
Yeah, right. So you have to find the longest contiguous subarray that's
Yeah,
divisible by k. So like you are saying that you will generate all the subarrays or something. So
yeah,
suppose that you are running a loop or whatever you are doing, so you can write the
mm,
pseudocode for that part only.
yeah.
Like what will you actually do here?
Yes, I can have the length is n for here over here, right? Then I can simply I have a sum variable which will be array of I initially, and then I can do for
So
j
basically, you
equal
are
to
saying
I
that you will
to n.
stand at a particular index I, and from that you will have a right pointer. So that will be moving one by one to generate all these subarrays.
Yeah, yeah, yeah. That will generate all this array. Yeah.
Okay,
Then
and
I
then
can
you
do some.
then okay,
Then I can do
complicity.
the array of j, and then I
Okay,
can have the answer
and
variable over
and
here.
okay, you will have the answer initially as what, 0 or maximum.
I can take the minimum, minimum as well. Minimum. Let's say minimum.
Yeah, right. Okay. Because if till the end
Yeah.
if the answer is int minimum only, then what does it indicate?
That means it does not have any subarray. I can directly say uh, 0.
Basically, yeah.
Yeah. Then I can simply answer max of answer comma j minus I. That will
Are you
have
sure
the
that
enter.
j minus I plus one or j minus I? Okay, so
I think j
basically, like,
minus
what
I.
will be the?
Yeah.
Can you quickly tell me what will be the time complexity of this approach?
Time complexity will be big of n square
Okay,
because I am checking for every subarray. It is also
okay.
creating a
So
loop
audience
inside
can
loop.
also tell me how they will do it. And now, can you tell me like how will you do it? How will you do it in in much more optimized time complexity? How can we do this?
Yeah, yeah, yeah.
Audience can also tell me in the chat, like you can also tell your approach, you can also tell the brute force approach and things like that. We are looking at your like I'm looking at your comments currently, so you can tell me how you can approach this problem now. Because can you think a little bit? Can you, like, I'll give you a hint. You have to think in terms of remainder. So if you look at the first array, so if you see the remainder part, like let's write the remainders. So if you are at array, so you just push an enter, and below it you write the remainder for corresponding values, and then tell me what happens.
Yeah, yeah.
You don't need to copy it. You can just put in, like, okay, you can copy the array, no problem. You just keep bring yourself down.
Yeah, yeah. Just, for, uh, let's say
Okay,
I
so you
have
write a remainder, corresponding remainder for every value with respect to
uh,
3. What will happen?
for every value. Let's say I have a zero index. For the two, will have the remainder as zero. Oh, sorry, remainder as two, right?
Just below 2, you keep on writing. Just below that element you write, so you can have the space bar so that we can understand better.
Yeah,
No, no, no. I'm saying that you're like, okay. That's also fine. No problem.
yeah, yeah. For
Now you can tell us.
it will have the two remainder. When you
Okay.
sum the nine, and it will become nine, right? So nine will have the zero remainder, and then when we sum
Why are you
of
taking the
all,
sum? Why are you taking the prefix sum?
because it will reduce the time complexity because I have to sub array, right? Sum of the
So,
elements
so
divisible
suppose
by
that a
3.
particular prefix sum becomes 0. In that case, what happens? Suppose that a
If
particular, like,
after
suppose a particular prefix sum is actually divisible by the remainder. So that means the remainder becomes 0. In that case, what happens?
can you repeat it again? I just
I'm
lost.
saying that like every time the prefix sum will get on updating. So suppose that at particular point of time, if the prefix sum is divisible by k, in that case, what will happen?
I think we have found our sub array.
Okay.
think.
So
Yeah,
like you are saying that from the starting till some point of time, till some index I, you will be able to find it. But
yeah,
can
yeah,
can you tell me how, like there's one, like if you're saying that you will consider all those subarrays, in this approach you will consider only all those subarrays which are starting from the zeroth index until some ith index, they are giving me the remainder as zero for the sum. But can you tell me what, like how can I tackle with this situation for the internal subarrays?
yeah.
For the sub-arrays which are not starting from zeros, for the internal sub-arrays, how will I do it? So first of all, you write the remainder part for every prefix that you have generated.
By 3.
Yeah, carry techies is right. We will get the
Yeah,
small,
yeah, yeah.
maybe we can get the smallest, like we can get an answer, but that will not be longest, right? In some internal
Yeah.
sub-array can be the longest as well. Okay, so you can
Is
first of all
0
array is written, then below it you write the prefix, and then you can write the remainder, so you can also understand this thing better.
Yeah, yeah. Um, Also the prefix sum I can write also.
Yes, that is what I'm saying. Like the first line is array, then maybe you can write the prefix sum, then you can develop the prefix sum, and then you can tell me that what is going to be the corresponding remainder, so that you can observe something.
Yeah, yeah. Let's say 2, 9 plus
Okay, Vishwajit, your approach is very close. Like you are very close to the answer, I think.
6,
Okay.
20, 25. Prefix sum and then so,
Gaurav is thinking in a different dimension. Gaurav, you need to think a little bit more. Okay, so can you tell me,
okay,
is there
okay.
some repetitions or something?
Yeah,
Like
yeah, yeah,
audience
yeah.
could also see. Yeah, so what's the repetition? I can see that remainder 2 is there, then
Yeah,
at the
remainder 2 is 0.
and then again
Then
remainder 2.
hmm. Then the 0, then again remainder 2 comes. So I can say that this will be the subarray which have
So
the
why is the remainder,
um
why is the remainder getting repeated? Can you tell me, can you think of something? So that particular segment, like if you see those four elements, right? So if you see the
yeah,
second
yeah.
element, third element, fourth element, and fifth element, so the remainder is repeating. That
Mhm.
means the remainder in that range remains the same. So that means for that range, the remainder is zero. Why is that so?
Because of the I think the prefix sum, right? I mean, because I'm adding the prefix sum and then I'm
Okay,
also doing the remainder.
so tell me this thing. Suppose till a particular position, you just write it below. Suppose till, like how can you represent a number? A number can be represented as what? Let's say it can be represented as let's say p into k plus some remainder. Okay, p into k
Yeah,
plus
yeah, yeah.
remainder. The prefix sum can be
Yeah.
represented as p into k plus remainder. And let's say there is
Mm-hmm.
another prefix sum. Let's say there is another. You can write this first of all, let's say remainder, like the first, let's say rem1, right? You can write rem1 is equal to what? Rem1 can be represented as p into k, definitely, like maybe p into k or something like this. Yes or no?
Okay.
P into k plus
Yeah.
like basically the prefix sum, you can say. Okay, basically
Yeah, yeah, yeah.
you can say,
Yeah.
not the
The
remainder, so you
previous
can remove the
value
remainder.
plus yeah, 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 prefix sum, yeah. Because
So you can just write it. I'll tell you this thing. 1 second. So basically, 1 second. Yeah, here. So if you will see here, right? So I can say that one of the prefix sum can be p into k plus the remainder, right? Plus the remainder. And for another number, like let's say there is another prefix that I've taken remainder of, so it can be represented as q into k plus the remainder. Yes or no? And what happens? Like the remainders can be different or the same. So suppose if the remainder is same, then what happens? Then what happens? If the remainder is the same,
then I can say that the previous remainder is also same. I mean, starting number will. I mean,
so
if the remainder comes same,
you tell me in this range. You tell me, like if the remainder is same there, remainder is same there, then I'm getting that
yeah.
divisible by. So basically, what is the sum of that range? Can you tell me what is the sum of that range, which is having the same remainder as two? What is the sum of that
Um,
range?
some of the some of the range
Sum of
is
elements of that range.
Okay.
Can you tell me the elements?
Yeah, yeah. Second, third. I mean, first, second, third, fourth elements. Yeah.
So basically 7, 6, 1, and 4. So are these
Yeah,
elements
yeah, yeah.
divisible by 3?
Yes, it is divisible by
Uh,
3.
because if you see 20, so 20 will be represented as what, right? You see the till there the prefix sum, till 4 the
Is
prefix sum is
20.
20. Okay, so
Yeah,
20 will
yeah.
be represented as what? 20 will be represented as what? It will be represented as in terms of 3. So it will be represented as 6 into 3 plus
6 into
2.
3 plus 2. Yeah.
Okay, okay, and then how will you represent this number? Uh, 2. How will you represent it?
16. And 2 times 5 plus 1.
No, basically I'm saying that 2 is repeating, right? Basically the remainder, like
Yeah,
starting
yeah,
the
yeah.
first element. So if you have to write 2, so 2 can be what? 2 can be nothing but 0. Like 2 is what? 2 is nothing but what? 2 is nothing but this thing. 2 is nothing but like 0 into 3, 0 into 3 plus what? Plus 2. Yes or no?
Plus 2. Yeah.
Okay. So
You
what
can
happens
write
now?
like
What happens now? So can you observe? If I subtract these two elements, then what happens? If I subtract these two, then what happens? So can I say that if I do p minus q, okay, if I do p minus q, then what happens? Like not p minus q, basically the first minus the second. So it will happen like
mm-hmm.
it will be what? It will be like k into p minus q into p minus q plus 0, right? Plus 0, because basically if the remainders are same, so this expression, like this is the prefix sum 1, right? This is what? This is the prefix 1,
Yeah, yeah.
okay?
Prefix
This is the
1.
prefix 1.
Yeah.
This is the prefix 1, and similarly there is a prefix 2, right? As people have told
Mm-hmm.
in the chat as well. So this is the prefix 2. So if I
Mm-hmm.
subtract the prefix 1 and the prefix 2, then the expression that I'm going to get is k, like p into k minus p into q into k. So that's nothing but k into p minus q, right? Okay. Now what you will
Mm-hmm.
get is plus
Yeah,
0,
yeah, yeah.
because the remainder is the same. And now if you see,
Yeah, yeah.
this particular expression is divisible by k. Okay, everyone can write understood in the chat if they have understood this thing. I hope so. Have you, like,
Divisible,
you
yeah,
observed this
yeah.
thing?
Divisible by k. Yeah. Uh,
Okay, so now can you tell me how will you do it? Now can you quickly tell me, since we are running out of time? If the audience has understood this fact, then they can write a yes or a plus one in the chat. Harsh Shivasto is saying right. Then the length becomes I
yes.
plus one if from the start. So like now, what will you do? Like, which data structure do you think will help you to do this thing? That whether you have
Yes.
seen a particular
I
remainder earlier or not.
think the hash. Yeah, I think hash map
Okay,
can
you
do
will
the
use
job
the hash
for
map.
every index. I can store the, yeah, for every remainder. I can use the index. Let's say 2
Okay,
comes at
okay.
the 0 index.
So now you are clear with this part, that where like you will store the first index of the remainder, and then you will keep on comparing, like whenever the remainder repeats, so you will say that I minus map of remainder is going to be the distance,
Yeah,
right? You are saying this thing, maybe
yeah,
this kind of a thing. But
yeah,
suppose
yeah,
that if the number
yeah,
is
yeah, yeah,
negative, in that case what happens if the number is negative?
yeah, yeah.
If suppose that the prefix sum becomes negative, so don't like, like what will happen in case of negative numbers? Can you think of this?
The remainder will also get negative, I think,
Okay.
when, yeah, um, let's say minus 7 over here, right? Less for minus 7. The 2 plus
Basically, when
minus
the
5
numbers are
and
positive, then you can use the map smartly. But if
yeah,
if the numbers start becoming negative, then the prefix sum can also become negative. In that case, you need to think a little bit more. If the numbers are negative, so in that case, what you need to think of is, you need to think of like like when you divide a number by k, so the remainder can be positive as well as negative, because
mm-hmm.
if I talk about a number, if I talk about a number, if I talk about let's say if the remainder, let's say 3, if the remainder is 3, okay, suppose can you just scroll like I I'll okay, one second. Suppose if the remainder is equal to let's say it's equal to minus 4. Okay. Suppose it's equal to, maybe let's say it's equal to minus 1. Maybe it's equal to minus 2. Suppose. Okay. So one of the things
Mm-hmm.
that I can think of is, like, maybe the number could be of this kind of an expression, that the number could be something like this. Maybe let's say what it could be. It could be, let's say, minus 1. Okay, minus 1 into 3, because I'm saying k. So minus 1 into 3, and then maybe minus 2. Suppose that the number is 5. Okay, suppose that the number is actually 5. Okay, so it can give me
Mhm.
remainder like this, or I can also represent the number. Like, can you think how can I represent the number? If I want a negative remainder for him from it, if the number I'm saying is minus 5, then I can represent it like
Yeah.
this. Okay, then if you take minus 5 mod 3, then it will give you maybe minus 2. But another way of representing it could be that I do minus 1 into 3. So what will happen then? So it will, like,
Um,
no, like basically if I do minus 2 into 3, then what will happen?
it will have the minus 6, minus
Minus
6
6
plus
and
1, minus 6 plus
plus
1.
1. Okay, yeah.
Yeah.
So can you think how can I make the like this positive?
Um,
Uh-huh.
I can have the larger value than this. I mean, let's
No,
say,
basically what you will do is, if can you tell me a relation between minus 2 and plus 1 with respect to k? Can you tell me a relation? Suppose k is equal to 3.
um,
So if I add k to minus 2, then it becomes 1. So whenever the remainder is becoming negative, so to take care of it, you can add k to it so that you can have the positive remainders every time. And then for the positive remainders, you will, if you will check, so you'll get the most optimal answer. Like, you'll get the right answer. Okay, is that clear to everyone? I hope that is it is. So like
yes, 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 yeah.
okay, so this was the mock interview for today. Now Vinit, can you would you like me to give a feedback about you?
Yes, yes, yes,
First of all, tell me, did you like the session?
yes, yes. I really like the session. Yes,
Did it help you to grow? Did it give you actual feeling of an interview?
yes, yes, yes. It gave me really good
Okay.
marking.
So talking about the feedback part, so I think, like, I saw that your linked list was very good. Like, you had some good knowledge of basic knowledge of linked list. But when I gave you the question as well, so you were telling me that you will write the code like this and like this. But when I gave you the coding link, when I gave you the link to submit the code, then you can see that your code was not getting accepted. So it was not the most accurate code, not the most optimal code that you wrote. So this is something that you need to work upon. And another thing is that maybe I think you, with practice, you need to solve a little bit more problems so that you can be a little bit more efficient, right? I will say this for the audience as well, that if you have seen the longest subarray with sum 0, longest subarray with sum k, so you should also solve this kind of a questions: longest subarray divisible by k, or you should think about them. Okay, so +1 in the chat if you like this session. Everyone can give me a +1 in the chat, and hit the like button as well quickly, guys. Okay, so thank you, Vinit, for watching, for joining in. Now I'll talk to the audience. So everyone, if there is someone who feels like, I hope that you like the problem sessions, problem links for today. The first problem that I took was adding polynomials represented as linked list. So it was Amazon question. The second question was from Microsoft. So I hope that all of you did like it. In case if you did, so make sure to share it with your friends so that your friends can also have the maximum benefit from it. And if in case if you want to give the mock interviews, so definitely you can, the link will be in the description, and you can join them. And make sure to share it with your friends if they are preparing. And this was it from my side for today. Thank you everyone for joining in, and I hope that you have a great day tomorrow, and keep coding, guys. Thank you.